Quantum effect is matter and energy behavior that is not predicted or explained by classical physics, but is predicted or explained by quantum theory. So we're looking at behavior of matter and energy that cannot be predicted or explained by classical physics. So an example of classical physics would be an apple falling from a tree. Well, matter and energy, the apple falling from the tree, can be explained by classical physics. So we're not looking at those types of matter and energy behavior. We're looking for matter and energy behavior that cannot be predicted or explained by classical physics, but can be predicted or explained by quantum theory. Let's look at an example. Here we're looking at what's known as the photoelectric effect. We have two particles called photons. The photons are represented by the small gamma. These two photons have energy. They are traveling like a wave towards a bar of metal. The bar of metal contains atoms surrounded by electrons. The two individual photons traveling like a wave strike the electrons bound in the metal, liberating the electrons. The photons give energy to the electrons bound in the atoms within the metal, liberating the electrons from the bar of metal. This effect, known as the photoelectric effect, cannot be explained or predicted by classical physics. We need to find something else that can explain this matter-energy behavior. The matter-energy behavior that can explain the photoelectric effect is known as quantum theory. Now, ironically enough, quantum theory can be used to predict classical physics. So quantum theory can be used to explain the apple falling from the tree. But classical physics cannot be used to explain quantum theory. So we're looking for matter and energy behavior that can be explained by quantum theory. This is what's known as quantum effect.